Previously, we talked about uniform circular motion. We call it UCM, and we figure out the position, velocity, and acceleration as functions of time t. So now let's think about in detail the velocity of such a uniform circular motion. And let's look at the velocity expression here. So Vx equals negative omega r sine omega t, and Vy is omega r cosine omega t. Now, this velocity is a vector, and we call it v, and v of course can be written as vx I hat plus vy j hat. I hat, j hat are both unit vectors. Now the position x is r cosine omega t, and r sine omega t. And its vector form is, of course, xi hat plus yj hat. Now let's do something here. Let's do a dot product of v and r. So if you don't know what dot product is, you can review the lecture videos and in chapter 1, where we talk about the dot product. Okay, so so its operation is the following: v dot r is given by vx times x plus vy times y, becomes this expression. Okay, so now let's plug in these expressions for x and y, and also vx and vy. Let's see what happens. So x equals vx equals negative omega r sine omega t. X is r cosine omega t plus vy is omega r cosine omega t, and y is r sine omega t. Now we can see these two terms are exactly the same, and they have opposite signs, so they exactly cancels. So that's the calculation of dot product using component form. We can also calculate the dot product using the magnitude and angle. So it's given by v's magnitude times r's magnitude times cosine theta. And theta is the angle between these two vectors. So let's say this v and that's r. Theta is the angle in between. Okay. So now in order to get to 0 here for the dot product, since v and r are both non-zero, so the only possibility is for cosine to be 0. So theta equals 90 degrees. Okay, so that means that the velocity and the position vector, they're perpendicular to each other. So if I draw these in the picture, I will draw a velocity pointing at this instant, pointing this way, right, since they form 90-degree angle. So the velocity is along the tangential direction. In fact, this result is general, even for like any curved path motion. Suppose we know the object is moving along these paths, then in order to know the velocity, we simply just need to draw a tangent direction. So that's the velocity direction at this instant. And if I want to draw it here along these paths, then that will be velocity along the tangent direction. And maybe here, then that's the velocity direction along the tangential direction. That's a general result. Again, they form 90-degree angle. V and R are perpendicular to each other.